Hey everyone, in this lesson we're talking about the metabolism and absorption of sugar substitutes or artificial sweeteners. So this will be a quick lesson on many of the common sugar substitutes we see in our day-to-day lives. So the first one I want to talk about is aspartame. Aspartame is kind of the very well-known sugar substitute. It is also known as NutraSweet. It is about 200 times sweeter than sucrose, and it's metabolized in the gastrointestinal tract, and its products of its metabolism are actually absorbed in the GI tract. And one of those products is aspartic acid. So if you look at the structure of aspartic acid here, you can see that it is the same structure that I'm circling right now. So this is the aspartic acid portion of aspartame. Now another portion of aspartame that gets released is phenylalanine. Phenylalanine is a amino acid, and you can see here that this structure here is phenylalanine. And phenylalanine is important because a lot of times with individuals with phenylketonuria, they have difficulties metabolizing phenylalanine. So this is important to know that phenylalanine is a product of aspartame metabolism. And another product of aspartame metabolism is methanol. Methanol is actually, very interestingly, a toxic compound that we normally don't want to ingest, but is in fact actually a product of aspartame metabolism. It's in small amounts, but it is important to recognize that it is also a product of aspartame metabolism. Some other common sweeteners include stevioside or steviol. These are just other names for stevia. And stevia is also a artificial sweetener that you can commonly see in many dietary foods as well. So stevioside or steviol or stevia actually is a plant-based compound from the Stevia rebaudiana or rebaudiana plant. I'm probably mispronouncing this quite badly, but this compound is 300 times sweeter than sucrose. And what is special about this compound is that it is not absorbed at all. So if it's not absorbed, we actually don't get any metabolism of it, and we don't get any calories from this compound. Now another compound that is common is cyclamate. This is also known as sugar twin. Now sugar twin is about 50 times sweeter than sucrose, and it is not completely absorbed. It is slightly absorbed, but not completely, and it is not metabolized at all. So this is another very important compound because it is not metabolized at all. And again, since it's not metabolized, it is not actually contributing to any calories in and of itself. Now another compound is sucralose. Sucralose is also known as, or its trademark name is Splenda. And most of sucralose is not absorbed, and the rest of it is not metabolized. So this is, again, very important as it is not going to contribute to calories in and of itself. And it itself is about 600 times sweeter than sucrose. And another sweetener that we can see in different parts of the world is acesulfame potassium. This is also known as sweet one or E950. And this is about 200 times sweeter than sucrose. And it itself can be metabolized and degraded to acetoacetamide. So these are some of the common sweeteners we see in our day-to-day lives. Now, some of the important points to note about these compounds are that many of them do not contribute calories in and of themselves, but they may have some other unintended effects. For instance, there has been some ongoing research as to whether some of these compounds can affect our intestinal bacteria or our gut flora. And this could lead to changes in our intestinal absorption and metabolism of other foods and nutrients. So it's important to wait for future research to see whether some of these compounds affect our intestinal bacteria. Now, some of the other artificial sweeteners that we can see are sugar alcohols. These are naturally occurring. They contain fewer calories than sugars, but they still contain calories. And they are non-cariogenic, which means that they do not cause tooth decay or cavities. Now, one of them is sorbitol. Sorbitol is a sugar alcohol. You can see that there are many hydroxyl groups attached to this compound. And sorbitol itself is about half as sweet as sucrose. It has a low absorption from the GI tract. It is hyperosmotic, which means that it can pull water toward it. And it can lead to a laxative effect. If you're consuming a lot of sorbitol, it can actually cause diarrhea due to its hyperosmotic effects. And importantly, sorbitol is metabolized to fructose via the enzyme sorbitol dehydrogenase in the polyol pathway. So that's why sorbitol actually can contribute some calories because of its metabolism to fructose. Fructose can then be broken down in the fructolysis pathway. Another sugar alcohol that we commonly see is xylitol. Xylitol is similar to sucrose in its sweetness. It has low absorption from the GI tract like sorbitol, and it itself is metabolized and processed in the pentose phosphate pathway. And the last sugar alcohol we're going to talk about is erythritol. Erythritol, its trade name is Truvia, and it's about half as sweet as sucrose, and it has significantly less calories than sorbitol and xylitol, and the reason is because it is absorbed but does not become metabolized. So this is a big reason why it is doesn't contribute as many calories. So these are the sugar alcohols, and really the only difference between each of these sugar alcohols is the amount of carbons each one has. Sorbitol has 6 carbons, 1, 2, 3, 4, 5, 6. Xylitol has 5 carbons, 1, 2, 3, 4, 5. And erythritol has 4 carbons, 1, 2, 3, 4. So this is really the only difference between these sugar alcohols, and this can alter their absorption and metabolism accordingly. So anyways, guys, I hope you found this lesson helpful. This was a quick lesson on the metabolism and absorption of sugar substitutes. If you found this lesson helpful, please like and subscribe for more videos like this one. And as always, thank you so much for watching, and I'll see you next time.